Welcome to a question about NASA, and they are launching a rocket at t equals 0 seconds. Its height in meters above sea level, track with you right here, as a function of time is given by this equation. So here's an equation. NASA's launching a rocket. Okay. Assuming that the rocket will splash down into the ocean, at what time does the splashdown occur? It might be helpful to have just a little bit of a graph. You don't really have to do that. Okay, so NASA's launch number. This is time, and and we're wanting to find out, and this is the height, right? Because h, that's like our y, it goes on the y-axis, and time is our x. Okay, and so notice if you plug in 0 for time here, if you plug in 0 for time, that these are going to just drop out and you get 192. So that means the rocket is launched from a height of 192 when time is 0. See how I know that? When you plug in 0 for time, these drop out and the height just equals 192. That means they started the rocket, they launched it from a height of 192 feet, like up on a podium or up on a hill or something like that. They launched the rocket, okay, at 192. This is the initial height. When time is 0, h will just equal 192. So right here, when time is 0, you start at 192. And then this is it's a t-squared graph, which is a U-shape, and it's a negative t-squared. So it's a negative. So it's an upside down U-shape. So that means this rocket will do something like this. It'll take off and come down. And this right here is when it lands in the water. It's the water. Splashes down. And this is its max, or its peak. So see how I'm getting all that? I'm just looking and say, well, look, this is a negative t-squared equation, which means a U-shape upside down. It's starting at 192 when time is 0, right? It's h on the y-axis, time on the x-axis. It goes up, hits a peak, and splashes down. It's generally what any negative x squared or t squared graph is going to do. Is going to be a parabola, U-shape, upside down. Starts at 192, comes down. All right, now ready for the first question. It'll splash down after how many seconds? So what is this time here when the rocket splashes down? That's what they want to know. Let's write this. At what time? The rocket splashes down at what time? What is that time? How am I going to find that? Well, notice it splashes down when the height is 0, right? Splashes down when the height is 0, right? When it hits right here, its height is 0. Right here, the rocket's at its maximum height. When it splashes down and hits the water, its height is 0. So it splashes down when the height is 0. So if we want to find when it splashes down, h is going to be 0. So if I take that equation they gave me, which is h equals right here, minus 4.9 t squared plus 85t plus 192, and I plug in 0 right here, right? Because at the moment of splashdown, the height is 0. So now I want to solve for t. Find the time. Find the time when height is 0. Find the time when it splashes down, when the height is 0. So how do I solve this equation now? This height equation, which is now 0. When is the height 0? Find the t that makes this equation true. How do I find that time? Well, you know what we do whenever we have an x squared equation? We do the quadratic formula. A, B, C, right? A is negative 4.9. B is positive 85. C is 192. Going to plug into the old quadratic formula. Remember that thing? So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me give this extra space here. So there she blows. Let's come on over here. All right. So we got negative, and then we got b. What's b? 85 plus or minus the square root of b squared. 85 squared minus 4 times a, which is negative 4.9, times c, which is 192. Exactly. Thought we had enough space, but I guess not. All over 2 times a, and what is a? Negative 4.9. Okay, so I plugged everything in there, right? This is the b, this is the b squared, this is the a, this is the c, and this is the a. Plugged it all in there. Let's crank her out. So using your calculator, I'm going to grab my calculator and calculate. So I'm going to do that 85 squared first off. I'm getting 7,225. And then here, notice this is negative times positive. So that's two negatives. It's going to be positive, huh? See what I'm saying there? Comes out positive 3763.2. Run out of room again. On the bottom, be negative 9.8 as multiplied 2 times negative 4.9. See what happened up here again on the top? Negative times positive. So just count your negatives. That's one of the main places people mess up. Count yours, 2 negatives and a positive. 2 negatives multiplied to be positive, right? All right. Let's keep her going. So then we're getting closer here. I'm getting negative 85 plus or minus the square root. So add those together. And I'm getting 10988.2, and the bottom still is negative 9.8. Okay. So that means we have two possible answers. I'm going to break them into the two cases. So we have negative 85. Yeah. Here. Oh, come on. Plus the square root of 10988.2 over negative 9.8. Or same thing with a minus. Right? Negative 85 minus, because it's plus or minus. So I do the plus there and the minus there. 10988.2 over minus 9.8. So let's crank both those out in the calculator. Make sure you hit equals or enter on the top before you divide by the bottom. If you that way you'll divide the whole top by the bottom. If you just type in the last thing and then hit divide right away, you'll only divide the last number by the bottom. So be careful there. So let's see, what do we got? 988.2 equals divided by 9.8 equals. So I'm getting for this first answer, negative 2.0229. Or the other answer, no, minus square root 988.2 equals divided by 9.8 equals positive 19. It's kind of scribbly there. 19.369 and this other one was 20229.1. Okay, so there's my two answers. Now what are those? Those are both time, right? Remember, this was, how do we know? Well, because we're solving this equation for t, for time. So these are the times. Time equals this, or time equals that. So this one we throw away, negative time. That's back in time, right? That we can't do that. So here's our answer. There's the time when the rocket splashes down. It's 19 seconds. These seconds, I'm assuming. Let's see. Yeah, seconds. T is in seconds. So 19 seconds. That's our answer to the first part. 19.36985 seconds after the rocket is launched, it splashes down in the ocean. So that's how we do that first part. You just take the equation, you make height 0, because when it splashes down, the height is 0. Put in a 0, and then you got this x squared or t squared equation, quadratic formula. Plug it all in, get your two answers. Throw away negative time. That's backwards in time. So there's the real answer. Secondly, the rocket peaks. Now, how do we find where the rocket's going to peak? Well, right here's the peak. Here's the peak. What do we know about the peak? That's the vertex of the rocket right there, isn't it? That's the vertex of the rocket. And how do we find the vertex of a rocket? Do you remember? I mean, the vertex of a U-shaped graph. Remember how to find the vertex of a U-shaped graph? Maybe it'd be beneficial. I probably should have had this ready. Let me just dive back to the notes here real quick with you. How do we find how do we find it? There's an example of a nice little picture. Look at that right there. Let me bring that one over for us. It shows the exact story we are talking about. Let me add it in right here for us. Boom. There we go. So this is from the notes right here. So from the notes, it shows a little picture and finding time and height. So how do you find this right here? The max is at negative b over 2a. Remember that? That's the center, the vertex of a parabola. And normally we say x equals negative b over 2a. In this case, it's the t is x, t-axis is negative b over 2a. So the max height is the center when x of a parabola, the vertex of a parabola, x is negative b over 2a. In this case, t equals negative b over 2a. So that's what I got to do. So I got it where I'll just do it right here. So I'm probably making you sick by whipping this up and down. Sorry. So I'm going to go, okay. So I'm going to take this equation, find the peak. It's going to be t equals negative b over 2a. That's how you find the center, the vertex of a U shape, the very top or the very bottom, the vertex of a U shape. It's x, or in this case, t equals negative b over 2a. Okay, so and our equation is h equals negative 4.9 t squared plus 85t plus 192. So this, you know what we're talking about. This is the a there. This is the b. This is the c, right? So negative b over 2a is going to be negative, and then what is b? B is 85 over 2 times a. 2 times a is 2 times negative 4.9. So that's negative 85 over negative 9.8. We get these two negative signs. Going to be positive. Divide that on my calculator. I'm getting 8.67. Whoops, I don't have a positive 8.67346. That's t. T equals T equals, right? So see what I did there? And that's what they want, right? Oh no, they want meters above sea level. Okay, well, and we'll get it. Well, that's the beginning. This is the first part. So that's the time. That's the time. So the time is negative b over 2a. So I did negative b over 2a. A happens to be negative, so the bottom is negative. We got a negative in the front, two negatives positive. So that's the time, 8 seconds, 8.67346 seconds after the rocket is launched, it hits its peak right here. But they didn't ask when. Notice they asked, how high will it get? How high up is it right there? Well, that means now, and you can tell right here what you do. So the max height, you find your t, plug in x, also called t, to the height equation. Now they're going to plug in whatever that t is, boom, and boom, right? Because you want the height. So now I take this height equation, which is negative 4.9 t squared. So I'm going to plug in that t value we just got right here, 8.67346 plus 85, and then t, whoops, is again 8.67346 plus 192. Just making sense. I just plugged in t right there, plugged in t right there to the h equation. I just plug that t in. Now use that number on your calculator. And calculate it. I'm getting h equals 560.62244. So that's how many meters, how high up. That's our final answer. That's what goes right here, 560.62244. That's how many meters above. That's how high up it's going to be at its peak right here. So you see what we did there? There's two parts to it. To find the peak, you got to first find the time. Time formula is negative b over 2a. That comes from x equals negative b over 2a, which is the center of a U shape, the vertex of a U shape, which is the very top. It's the center of the U shape. So you plug that in, negative b over 2a, get your time, and then take that time and plug it into the height equation because you want to know how high is the rocket at that time. That's what the H equation is about. It tells you the height of the rocket at any time. So plug in that time, work it out. Here's how high up that rocket is at that time. So it's exactly what these instructions say. Time and height at the maximum. And we found it. And so there we go.